Moving on, we will be having another talk about comprehensive guide on modeling with machine learning with our speaker, Heba Youssef. The floor is yours.
Okay, so hello everyone. I hope you can see my screen, first of all.
Yes, we can.
Okay, that's great. So I'll just introduce you first with my aim with this presentation. I don't like that everyone mentions machine learning, but then it's still ambiguous. Like, what is it exactly? How does it work? Is it magic? And all of these questions I wanted to answer with this like very simple guide that I try to just like summarize the main steps of building a machine learning model. Because in fact, anyone who knows a bit of Python and has internet can do machine learning. You can just like download that sets and then just start working on them directly. So my name is Heba. I now work at DIWA R&D Center in the Machine Learning and IoT department, and I'm still learning. I'm still in the beginning of my road, but I wanted to share this topic with you so that you can benefit as well. So first of all, a very important concept is a model. I wanted you to understand what is a model. And this is something that's very important even in physics or other sciences. I remember when I was in 12th grade, the physics teacher, like that was the first thing he explained when he entered the class, explained what modeling is. So modeling is an attempt done by humans to try to represent a system that exists in nature. God created some rules in nature that things follow, but in order for us to deal with these things and build systems our own, we need to understand, or we need to summarize how nature works in an equation or in words. So this is basically what is a model. I think I want to just like this down. I don't know if I can do that. Okay, that's fine. So as I said, a model is an attempt to capture the behavior of things in nature, in equations, or in words. So what we do is that we fix a target. For example, Newton saw the apple that we hate that I put here. Maybe you can't see it. He saw it and he wanted to target the force. I wanted to know what affects the force, what made it fall down. And similarly, for example, like velocity and distance and time, we fix the velocity, and then depending on its relation with other things, we can write an equation to represent that. And that is easy for easy systems. But how about complex systems, like, for example, human emotions? So I took this example. For example, my friend Fatma, who's attending now, I wanted to see her happiness level. So the parameters that I thought would contribute to her happiness were money, food, family relationship, grades, personality, and health. So in fact, these are very few. Humans are very complicated and there might be 100 factors that affect their happiness. But to simplify in machine learning, we take the most important factors and then we try to find their contribution each to the final target, which in this case is the happiness level. So the modeling happens like that. We first start by defining what are the parameters that I want to build my model on. What do I think contributes to happiness, for example? And this is in the data collection part. So you'll either find your own data, you'll collect it your own, or you'll use an open data set from, for example, these websites, Kaggle or UCI or Data Hub. And for me, I built my own. So what I did is that I put all the inputs, we call them inputs or features, and then I have the target, which is happiness. And you read the data set. This is how you insert the first step into the code. Afterwards, you will process. So processing is very important because the machine can only learn from the data you give it. It cannot depend on anything else. So that's why you have to make sure that the data that you inserted is actually representative of the reality. For example, if I want to measure Fatma's happiness, I have to make her do a survey for 1 year of her stats of everything, like how was her day, how was her relationship with her family, and so on. And I'll have to record all of that in a very accurate way. If it's not accurate, I'll need to clean it. So I'll remove, for example, duplicates of data. This affects this impacts the model if there are many duplicates. I remove mostly points and outliers. And outliers are data points that do not comply with the overall fit of the or the trend of the system that we have. And then I will check for imbalances. And imbalances are, I wish I put a picture here, but I don't have the time. But imbalances are when you have, for example, here in this table, when I have too many of this 10 in the happiness place. In that case, I will not know her exact level when we have, for example, level 1 happiness. I won't know what are the features that do that. So imbalances are very dangerous to the model, and we need to deal with them. And that is done using oversampling or undersampling techniques. And those are very technical, but the main point is that we try to balance the whole data set so that we can have an equal amount of each state. For example, I want 10 days of happy, and then 10 days of not happy, and 10 days of moderately happy, and so on. Afterwards, we do the feature selection, which is also important. There's a funny phrase that I like in machine learning, which is garbage in, garbage out. If you put things that are bad or that are not realistic inside the model will believe it and will build everything else on it. So it's important to choose the right features, to choose the right examples, and so on. And in feature selection, this is some people consider it as another step as well, but in the basic level, it's fine to consider it a part of pre-processing. And in the feature selection, what we do is that we find the relation between all the inputs to each other. In that case, if we find, for example, that money and salary are very related because actually they're almost the same, I can just use one instead of two of them. And that will make the model more simple, and it will make it perform actually better. And here I just put like a simple code of how to remove outliers and how to normalize, just for you to see that's actually not scary. It's just like identifying the IQR and then removing it, and that's it. Like removing anything that exceeds it. After that comes the testing. So in the testing, you have to choose, oh, how did I put the testing before the, okay, this is the slide that's supposed to explain now. So the algorithms, you hear about many algorithms like random forest, support vector machine, neural networks, deep learning, and so on. In fact, when you do the actual code, it won't make a great difference, especially between supervised machine learning algorithms. Because in the code, each algorithm is just like 2 lines or 3 lines. So what we do is that we try with several algorithms, and then whatever performs the best, I know that it's good for my specific system. And also, it's not very random as well. You can make educated guesses based on a previous work. For example, people use deep learning for facial recognition or for speech recognition and so on. So you already would have an idea about what to choose. But anyhow, if you are not a data scientist, you won't really deal with the architecture level of the algorithms. So you'll just use it as a tool to model whatever system you have. For example, for me as an engineer, I never deal with the parameters except for when I do hyperparameter optimization. So it's very simple. You just try as many as you want, and then you move to the next step, which is the optimization and enhancement. So in this case, you might think that after I did the algorithms, خلاص, I have the model is ready. In fact, it's not ready yet. You can always make it better. And that is by doing something called hyperparameter tuning. It's almost a random process, almost, but it's not very random. But you just try to change you try to change things on the low level. For example, the number of neurons in a neural network, or for example, the number of nodes in a random forest tree. So when you change them, you can find the model performing better. But doing it manually will, of course, take a long time. So there are ready-made optimization algorithms, such as Grid Search, Adam, or Grey Wolf. And the good thing is that in this field, in the machine learning field, the community is very open. So you can find people suggesting new algorithms and designing new algorithms all the time. And you find them named with funny names or like the person's name or something. So it's really good to explore what's available and be updated on, for example, the best optimization algorithm to use for your problem. You'll always find the new things being proposed. So after you do the optimization and enhancement, you do the testing, which I put by fault, like here, by mistake. So in the testing, you have already made your model. Now you need to see, does it perform well in real life situations or not? And this is not done only once. You do it in like in a cycle. You keep optimizing and then testing again, optimizing and testing. And you test or you decide on the best performance based on the metrics that you have. So if you have a regression problem, which means that all the inputs and the output are numbers, then you can calculate easily the MAE or MAPE or RMSE, which are just like errors that you can calculate using an equation. Or if you have a classification problem, which means that the output is not a number, it's something like true or false, then you can use the confusion matrix. And this matrix, you can calculate the accuracy and the F1 score and the recall and all of these parameters using it. Like there are simple equations defining true plus false over true or something. So these are all the main important steps. After you're done, then it means that you have your final model. This final model is a model that has an equation inside of it that you can't see. That's why it's called the black box modeling. So the equation might be regression that you can see, might be something else like a deep learning network that you won't be able to know what is the model doing. But what's important to you is that you give it a specific points. For example, in this day, Fatma has this certain amount of money, this amount of food, and this relationship, and so on. It will be able to give you her current happiness level. It won't be accurate 100%, that is expected, but at least it will be as accurate as possible. And this is all the summarized process. I hope you learned something from it, and please feel free to ask me any questions. I'll open the chat now.